Hello everyone, welcome to the class 1 lecture of the course FEA of Aerostructures through Patron and Astron. So in this course we are going to see how FEA plays a very major role in the analysis of the aerostructures, and you might wonder why it is not through hand calculations and why it is through. It's for the only reason that FEA can handle a very complex structure, and the real time problems in terms of complexity and in terms of the volume can be easily handled through FEA rather than the simplified hand calculations where we use the classical solutions or the closed loop solutions. So later in the course we are going to see the introduction to FEA, and then slowly I will be moving into the introduction to pattern and Astron. From there, and I'll be speaking more on the linear static analysis, buckling analysis, vibrations, and so forth. So before diving into the more detailed analysis of the structures and FEA, this class would be a more of introduction to the aircraft structures for the students who are taking up this course, who already have or who are undergoing the aeronautical engineering or aircraft engineering. This might sound a little bit basic because probably you might have already aware of the uh, parts and the preliminary structures of the aircraft, but it would help you to brush all your fundamentals. I hope you enjoy the course. Wish you all the best. So I'm going to start with the topics covered in class 1. First one is the basics of the aircraft structures. Second one is the fundamentals of the primary structures, because the entire course is focused on the primary structures rather than the aircraft secondary structures which are within the aircraft. And then I'm going to speak to you on the design and construction aspect of the primary structures and aircraft materials. So before going into the fundamental aspects of the aircraft structures, we should know the origin of the aviation. So there were two famous physicists by name George Cayley and Otto Lilienthal, who were the first few pioneers in the aviation field or the aircraft industry. In those days, they don't have the sophisticated modern computer system where we could now use to design the aircrafts and etc. So it's all by experiments. It's all by trial and error methodology. They came up with the concept of the gliders that one can fly for a few minutes. In fact, the Wright brothers, who came later on, they flew the first aircraft. I think it's only for 18 minutes or something, and then it fell down to the ground. So George Cayley, he was the inventor of the first glider back in the year 1799, where he developed the concept, and then he and by 1804 he flew his first aircraft. Those were made of just rods, tubes, and fabrics. He tied up together, and then he jumped from a hilltop, and then he flew for a few seconds and it fell down. And then further in 1891 and between 1895, Otto Lilienthal, he developed a glider which is attached to the back of the person, and then they have to run and they have to jump from an elevation, and then they could fly for a few seconds and they could land. So these were the earlier concepts of human flight, and then they came. Wright brother came, and then they designed a plane called biplane, which is which is of two pieces of fabric which is separated by the truss type structure, mainly some aluminum rods and tubes, and then they flew their aircraft. And then later on, as the technology developed and the manufacturing processes developed, and then slowly they improvised the aircraft design engineering, and then slowly the biplane, and then the glider type aircraft, and slowly it came into picture. And due to the advancement, and you can see the modern day glider, which is or the trainer aircraft, will be something similar to this. So considering what are all the primary parts of the aircraft, we have obviously the power plants, which is engines, and then the landing gears. Landing gears are nothing but the wheels and the strut attached to the wheels, and then the aircraft wings, and then the main body of the aircraft, which is called fuselage, and then the tail plane, which is the tail part of the aircraft, which is also called the empennage. And there are some surfaces or the flat panels which are controlled by pilot. They can move. When I say move, they can rotate about this axis, which is called flight controls. They can move up and down, so which is primarily used for the motion of the aircraft or the movement of the aircraft during flight and on the ground. So we are going to speak on that later. So time being, like the aircraft primary structures, we can classify the aircraft primary structures and secondary structures. What are they? When you see or when you observe, you can notice aircraft primary structures are mostly the structures which are exterior to the aircraft, or it is visible with your eyes, or it is outside the aircraft, where you have the fuselage, wings, stabilizers, landing gear, and nacelles and engines. And what are the secondary structures? Secondary structures are the ones which are go inside the aircraft, mainly the galley monuments. You might have seen the cabin crew serving food and everything. They usually, those food are stored in the galley monuments. Basically those are composite galleys. They are made of composite materials, and you can see the overhead storage where the passengers sit in. There is a overhead compartment for storing their luggages. So there's overhead storage, and seat racks, floorings, and under storage where your check-in baggages go inside, and then auxiliary power unit and cabin pressurization systems. Whatever secondary, whatever parts or whatever the primary components that have been classified as secondary that go inside the aircraft, whatever that have been classified as primary go exterior to the aircraft. So having classified the primary and secondary, let's see the functions for the purpose for what they have been used or what they are used. First of all, fuselage structure. Fuselage structure serves as a main body of an airplane. So there are pilot and cargo compartments, and obviously there are passenger compartments as well, and they are generally constructed in two or more sections. So any aircraft you take, whether it is a commercial VIP jet or it is a very large passenger aircraft, the fuselage is generally made of at least two or three sections. They call it as a forward fuselage, mid fuselage, and the aft fuselage. And they won't be constructed in a full section. Why? The reason behind, it is easy for maintenance. In case of any damage or in case of anything, they can remove the forward fuselage and they can replace it with. And also fuselage serve as a carrier, carries all the accessories and all other equipments, associated equipments that goes into an aircraft. And also it includes the numerous access doors, access panels, inspection panels, and other openings in the sense there are cutouts for the passengers, we call it as window. And then there are some emergency cutouts where we have the emergency doors fixed, and few other access doors that are used mainly for ground maintenance. And then the landing gear strut, where we have the landing gear strut, we have the landing gear bay where in a not in a smaller glider aircraft or something, but in a bigger proper passenger aircraft, where once the aircraft take off takes off, the landing gear folds and the landing gear bay closes. So in that way, like fuselage structure mainly carries the equipments and serve as a main body of an aeroplane. Moving to the wing structure, wings, they are mainly used for producing lift. They are the lift generating surfaces. So the cross section of the wing is airfoil. So I'm going to speak to you on this in a couple of slides. So at the minute I'll move on to the different things. So there are various size and shapes of the wing that we are going to see in a minute. So mainly wing structure is used for generation of the lift, and engines produce thrust. It is the forward force that propels the aircraft forward. So and then you can see the engines produce thrust by converting the chemical energy to mechanical energy, and it also drives propellers and fans. In case of turboprop aircraft, there are various different types of aircraft based on the engine arrangement: turboprop and turbofan. And also there are wing mounted or fuselage mounted engines, may be wing mounted or fuselage mounted. So the purpose of the engines are producing thrust to propel the aircraft forward. And then landing gear serves as the wheel. It's mainly important during takeoff and landing. They get a huge amount of loading that is transferred to the fuselage structure, and then they support the aircraft for the ground operation and maneuverability over on the ground. So as I mentioned, they absorb a huge amount of load that goes into them during the landing and takeoff, and also during the ground operation. And there are different types of landing gear that can be fixed or retractable, and those kind of types. The main purpose of the landing gear is to support the aircraft during landing, taxiing, and taking off. So the most important aspect of the aircraft physics is the force components that are produced when the aircraft is in the flight and is on the ground. So you see an aircraft which is in the flight, there are four types of forces that balance each other. Well, first one is the thrust, and thrust which is produced by the engines, which is produced by the power plants. And then the lift generated by the aircraft wings, and the drag and the weight. Weight is the self weight of the aircraft, drag is the aerodynamic drag due to the aeroplane shape. So if you see the horizontal force, thrust is balanced by the drag, and the lift should be balanced by the weight. So in that way, the during the flight it will establish the dynamic equilibrium, and the flight moves forward. So what exactly happens during the lift generation? If you see, this is called an airfoil or aerofoil, which is nothing but the cross section of the wing. As the air particles move past the wing, the upper surface of the wing, we creates a lower pressure region, and the bottom surface of the wing creates a higher pressure region. So obviously the air will tend to move from higher pressure to the lower pressure, and what will do is it will push the wing up, thereby generating the lift. So you can see the forces that act on the center of point or the center of pressure on the wing, where all the forces balance to produce an equilibrium effect. But in reality, during the flight, thrust will overcome the drag in that way, so the aircraft is moving forward. And this is a typical cross section of the wing that is shown here. So we saw the four types of forces that act on a typical aircraft during flight. And I'm going back to the previous slide. When it is on the ground, so you can ask what kind of forces act on the aircraft. When the aircraft is stationed and without moving, when the engines are not operating, then we will not have any thrust component, and we won't and the lift will be very negligible, because the when the airflow on the ground level, when it goes past the wing, it produces a negligible amount of lift. What will have is the predominantly the weight of the aircraft that is being pulled due to the gravitational force, and due to the shape of the aircraft, the wind on the ground level will produce some drag. And when the aircraft is moving or taxiing on the ground, there will be thrust because of the engines running. There will be small amount of thrust, and the pilot will deploy the flaps, which is the one of the flight control surfaces, just to produce lift, and thereby we will have mostly all the four components, and predominantly weight will be more because the due to the gravitational effect, and lift will be very minor, and thrust will be more. These two components will be more on the ground when the aircraft is taxiing. So moving to the next slide. So we saw the forces acting on the aircraft. Now we need to classify the loads that come onto the aircraft, which is much more important. So the aircraft loads, or the external loads that act on the aircraft, can be classified broadly into three categories, which is flight loads, ground loads, and the loads from the engines. So during flight we will have the maneuver loads, when the aircraft is taking a turn or when it is going up and down, and all those types of maneuverability loads that will come into flight loads. And the gust loading, gust is a sudden strong wind, or there is a vacuum packet, or something where it is drops and sudden effect on the aircraft structure, those all come under gust. And finally the landing loads and the takeoff loads, both takeoff and landing come under the flight loads. And moving to the ground loads, we have the emergency abuse load, where the ground personnel who are doing the maintenance or something, they might push and pull the door, very hardly, or it might be they are when they are moving the equipments around, it might damage the structure, whatever may be the case. So those kind of handling and abuse load come into ground loads, and cabin pressurization loads that also come under ground loads. And bird strike, it cannot be purely ground or it cannot be purely flight, because the bird strikes can happen both in the flight and also during the ground. There are instances when the flight is about to take off, the bird has hit. So it can be neither of the flight loads or ground loads, but I have kept it under other, just to make it a separate category where you can say that bird strike is a separate case. And then the loads coming from the engines. So these are all the loads that act on the aircraft structures. So one should keep it in mind. There are various possibilities of loads that can come onto the aircraft structure. So while later in the course, while analyzing, we'll realize that these these kind of loads, how do they transfer into the aircraft and how do they distribute within the aircraft structure. So there are three common structural elements used to describe the aircraft structure, which are skins, and then the stiffeners. Stiffeners are nothing but the small cross section beams that stiffen the skin panel, and then the beams. These are three types of commonly used structural element what you can see within the aircraft structure, and they require a determination of loads and properties, mm, which are mass properties. And we are going to talk about this subject in a very detailed fashion maybe later, but at the moment keep it in mind that there are materials that may experience both tension and compression for parts exceeding the yield stress and strain induced aerodynamic issues and the buckling. These are all the three predominant criteria that will be each aircraft structure will be checked against. So the moving to the types of loads that act on the aircraft structures, we have tension, which is pull effect, and compression, which is pushing, and then torsion, which is twisting, and which is shearing, cutting, shearing effect. So all the types of loads that act on the aircraft structures, they transfer, they redistribute themselves into one of these types of loads, with the skins taking predominantly the in-plane loads and the beams and stiffeners take the shear loads and the bending loads. So having seen the loads, we'll see the primary motions of the aircraft. Speaking about the primary motion of the aircraft, we have three primary motions, which are pitching, rolling, and yawing. Pitch, roll, and yaw. So pitching is mainly used for the aircraft to go up and down to gain the elevation and then to decline. While descending, it's used. So the primary control surface that is associated with this motion pitching is the ailerons and the elevator. Both can be associated with this motion. And with the rolling, it is only the aileron that is causing the aircraft to roll, and then it is the yawing motion is caused by the control surface rudder. So you might be wondering, what is this control surface? These are nothing but flat panels that are attached to the aircraft wings and aircraft stabilizers, where it will be operated by the hydraulic and pneumatic systems in the modern day aircraft. In those days aircraft, they used to be in the mechanical linkages that used to operate these control surfaces. They go up and down, so thus producing the desired motion of the aircraft. The pilot will, when the pilot deploys the elevator, when it is going up, it will produce the upward motion. When it is goes down, it produces the downward motion. And similarly the rudder, when it this portion alone, this flat surface alone will turn this side, and then the aircraft will rotate. Imagine you're sitting in the cabin, and this is your right and this is your left. Suppose the rudder turns to your left, indicates that aircraft will be moving to your left. So how it is working this way is due to the physics. When the aircraft wind, I'm sorry, when the wind is flying, is passing the aircraft, it surpasses the aircraft, it causes the motion, it causes the effect for the aircraft to move along the, it pushes this rudder, and then it will make the aircraft turn. Similarly, when the aircraft is in flight, you can see that one of the ailerons will go up and one will be down, and the side whichever goes up, the aircraft will roll to that side. So in that way the motion of the aircraft will be achieved. So if you see, there are three different axes. The first one is the longitudinal axis, which is also called fuselage axis, and the lateral axis, which is the aircraft wing axis, or the wing stations will be along this lateral axis, and third one is the vertical axis, which is the spin axis. So you can see the picture over here, you can understood. The longitudinal axis is used for rolling, lateral is used for the lateral is used for pitching, and vertical is used for the yawing. And you can see the forces over here. The lift is generated on the wing surface and drag simultaneously. Here you can see the picture. So one of the ailerons has been up and the other aileron has been down. So what would happen is, the on the down it would produce more lift, and the one which is on the up, it will produces a small component of lift. So it is not equal and opposite. So what happens, this will roll to that side, whichever is up, the aircraft will tend to roll that side. The same phenomena works, the same funda works for the elevator, and for the rudder it is the one which, the side which rudder moves, the aircraft will move. So this yawing motion and the movement of the rudder comes into picture only on the ground, but whereas pitching and rolling is during the flight and during the landing and takeoff. So you can see that these primary control surfaces of the aircraft, I'll go back to the previous slide where the aircraft pictured. So these flight controls or the primary control surfaces, it is also called control surfaces or just the flight controls. They serve the purpose to support the movement of the aircraft, and all other structure, primary structure, they produce lift and thrust and few forces that enable the aircraft to be in flight, or whether it is landing or taking off. So what are all these flight controls or control surfaces, they are just near the, they're just nothing but the flat panels, flat rectangular shaped panels that will be used for the purpose. Sometimes if it is an aircraft is a metallic aircraft, then it is a metallic panel. If it is a composite aircraft, then it may be a composite panel. But the wings are, if the aircraft is, again, if it is metallic, the wings may be aluminum alloy wing, metallic wing, or it may be a honeycomb sandwich wing. So these flight control surfaces or the just the flight controls, they'll be attached to the wing or elevator or the empennage tail portion. There will be a bracket, there will be a lug kind of structure that will be attaching these control surfaces, and there will be a wired connection, hydraulic or pneumatic type of wired connections that will be helpful, that will be helping the movement of the these flight control surfaces. When the pilot pushes the button, there will be, the movement will be achieved. So internally there will be the hydraulic system or pneumatic system that will transfer the effect to this flight control surfaces that will be. And for yawing, for rudder, there will be a pedal under the, it's there will be a pedal, something similar to the brake pedal in your car. So in each way you will deploy the yawing motion, like deploy the rudder using the pedals.